Good morning, everyone. Today we are going to be going through your 8-1-A-4 similarity test review for your upcoming test, and I posted all that information on Google Classroom. Make sure you watch this video in full because I'm going to go through, so not only that you have the review answer key, but you also have detailed worked out solutions to each problem in case you have any questions. Okay, and I'll pause it as I'm going through. Remember, you pause it, you go through it. But to do well on this, follow this video, and before the test, we'll answer any questions you have going into it. So first thing we want to find, it says find the scale factor, state the congruent angles, and rate a statement of proportionality. So we are told that LMN is similar to triangle QRS. Remember, the similarity statement tells us which angles are congruent, because the angles in similar figures are congruent, and which sides are proportional. So looking at this, we know that angle L, that's congruent to angle Q, so we can mark them congruent. And that's what it's asking us to list. Angle L is congruent to angle Q. We also know that M and R are congruent, so angle M is congruent to angle R. And we also know that angle N is congruent to angle S based on the similarity statement. Do not just go the way the angles are facing, or the way the triangles are facing, go by the similarity statement. That will tell you everything you need to know, okay? When you are finding a scale factor, you always want to start with, so it says find the scale factor from LMN to QRS. Remember, your scale factor is always new over old. So new over old, pick any two corresponding sides, which we'll talk about in a second, based on the similarity statement, and divide them. So new over old, so this would be 30 over 10, which equals 3. Remember, you can pick any two sides that are corresponding to one another. And what tells you the sides that are corresponding? So 39 over 13 would be 3, 18 over 6 would be 3. So either way, you would get your scale factor is equal to 3. And it's always new over old. Okay? When it comes to your statement of proportionality, you want to use the sides. So LM and QR are first. So we know that LM divided by QR would be the same proportion, follows the same scale factor as MN over RS, which would be equal to LN over QS, because they both come first and third in the statement. Now, if you flipped all of these, that would still be acceptable. Just remember that your scale factor may be different. The statements would still be proportional. So if I'm going to have everything from triangle LMN on the top, that's fine. Everything from the other triangle at the bottom. Okay, let's keep going. Number 2, in the diagram, it tells me PQRS is similar to WXYZ. So, judging this, I'm going to mark all of the corresponding sides. You can do it in different colors, different shapes. So I know that PQ is similar to WX, so I'm going to circle PQ, and I'm going to circle WX. Those two sides are corresponding. Then I'm going to do QR. Those are in the middle, and XY, they're in the middle, so QR and XY. And then we have RS and YZ. So YZ, RS. And then last but not least, we can mark the last two corresponding sides, the only ones that are left, however you want to do it, PS and ZW. Okay, so it says find the value of X. So we are going to create a proportion. One fraction equals another fraction, and we are going to solve this proportion. So it doesn't matter which two corresponding sides you pick to set up your proportion, just kind of like finding the scale factor. So I'm just going to do 15 over 8, the first two that I found. So if I'm going from this figure, PQRS, to this one, I need to go in the same order. So 15 over 8 is equal to X over 32. You have to use the X over 32 because you need to use X, because you need to solve for X. So set up a proportion. You could have done 75 over 40 equals X over 32. You could have done 105 over 56 equals X over 32. Make sure if you start with this figure, if 15 is on top, then X from the same figure also has to be on top. Okay, the bottom is from the other figure. And how do we solve something like this? We cross multiply. So 15 times 32 equals 8 times x. And we end up getting 480 equals 8x. So x is going to equal 60. And if your proportion was slightly different, so say you didn't use 15 over 8, you used instead 75 over 40, this will look a little bit different. Your proportion will, but your answer should end up being the same. If it does, you did something wrong. Okay? Next one, in the diagram, triangle NML is similar to triangle SRL. So let's look. So let's match up the corresponding sides. So here's one triangle, here's the other. So ML is corresponding to RL. So ML is corresponding to RL. So that means that NL and LS have to be corresponding. So I'm going to go from the left triangle to the right. So I'll do it this way. From left triangle, so 28 over 24 equals, we're going to set up a proportion. If I'm going from left to right, I have to go from left to right. 3x minus 1 over x plus 7. And again, you have to cross multiply. Be very careful. When you cross multiply here, make sure you are using parentheses. Parentheses around the x plus 7 and the 3x minus 1. I might go off the screen a little there. Okay, now don't forget to distribute. So 28x plus 196 equals, it will be 72x minus 24. And if you solve this, you'll get 220 equals, okay, so that would be 220. Let me clear this out. If you solve equals 44x, so x would equal 5. So a lot of algebra there, but as long as you set up your proportion correctly and take your time solving using parentheses, you will be okay. So x equals 5, and then we can find NL just by plugging in x. So 3 times 5 minus 1. And I'll put this here so that you don't forget. So it's just going to be NL is 14. Okay, let's continue going downward. So it says if triangle CDE is similar to triangle WXY with a scale factor of 4 to 3, find the perimeter. So remember, when they're giving you a scale factor, it's reduced ratio that if I were to divide all the proportional sides, it would get the same thing. So a scale factor of 4 to 3 is really like a scale factor of 4/3. So they want me to find the perimeter of the second figure. So what I'm going to do is I'm first going to find the perimeter of the first figure. So I'll call it, triangle number 1, triangle number 2, just to make it easier. So the first perimeter, I'm just going to add up 13 plus 22 plus 29. So my first perimeter is just going to give me 64 units. And I want to find the perimeter of my second figure, p sub 2. So all I'm going to do is set up my proportion. So we have a scale factor of 4 over 3, and that's equal to, if I were to divide the two perimeters, they should equal the scale factor. But what is p sub 1? Well, we already found that. We just added up all the sides, and we got 64. So now I have a proportion. I could cross multiply and solve. So 4 times p sub 2 equals 3 times 64. So I get 4 p sub 2 is going to equal 192. Divide both sides by 4. I get that it is going to equal 192 divided by 4. My second perimeter, the perimeter they actually asked me for, is 48 units. Okay, so they're already giving you the scale factor. They're giving you one of your triangles and your proportion. You just need to find the perimeter of the other one to find the final perimeter. Remember, you can pause this video at any time to go through it if you need to. So let's look at this next one. So it says your family has decided to put a rectangular patio in your backyard. Here is our rectangular patio, similar to the shape of your backyard. So your backyard is a little bit bigger than your patio, which makes sense. Your backyard has a length of 42 feet. So I'll just label the length 42 feet and a width of 18 feet. It says the length of your new patio, so the length of your new patio is 14 feet. Find the perimeter of both patios and both the backyard and the new patio. So it says a rectangular shape. Think back to rectangles. You know opposite sides are the same. So the perimeter for this figure, all we do is add up all the sides. 18, 42, 18, 42. So we're going to get that this perimeter ends up giving us 120 feet. So this is the perimeter of our entire backyard. We didn't have to do too much to find that. But we need to now find the perimeter of the patio. We do not know the width, but we don't need to because we can create a scale factor. So we could say, okay, our scale factor, divide the two lengths, is 14 over 42, and that's equal to our perimeter of our patio, so I'll call it little piece of P, over our total perimeter of the backyard. So I have 14 over 42 equals my new perimeter that I'm trying to find, my perimeter of my patio, over the perimeter of my backyard. It's just same thing. So length over length equals perimeter over perimeter. Cross multiply. 14 times 120 is going to end up giving me, and I don't think I wrote this out. So 14 times 120 divided by 42. So cross multiply and divide, and you'll get about 40 feet. Okay, so you'll end up solving and you'll get 40 feet is the perimeter of the patio. Remember, the perimeter of the patio should be smaller than the perimeter of the entire backyard. That just makes sense. Okay, and let's go over to number 6. So number 6 is fairly similar to number 5. It says a 32-foot tall building. So we have our building here. Casts a 12-foot shadow. So the building is 32 feet tall, and it's casting a 12-foot shadow. We're basically creating like a little triangle here. So this is our building, and it says at the same time, a tree nearby casts a shadow that is 9 feet long. So here's our little tree, only fitting I'll do it in green. So our tree's shadow is 9 foot long. How tall is the tree? So let's set up a proportion. We're gonna the corresponding sides, so the heights of both, so 32 over t, so the height of the building over the height of the tree, equals the length of the shadow over the length of the shadow. Make sure if you're going from left to right, you go from left to right, okay? Now you're just gonna cross multiply and solve, and if you do this, 32 times 9 divided by 12, you're going to get that the height of the tree, or with the variable we're calling t, is equal to 24 feet. Okay? And if you get, maybe you set up your proportions slightly different and you still got to the same value, that is okay. As long as you can show me the work to support it, there are sometimes different ways to do it. Okay, let's keep going 7 through 10. So it says in 7 through 10, determine if the triangles are similar. If not, right, not similar, and if they are, state one of the 3 similarity theorems and complete the similarity statement. So first off, we have nothing about the angles here, so we're not going to be using angle, angle, or side, angle, side. So we're going to first we have to match up all the corresponding sides. Question is, how do we do that without a similarity statement? Well, we did it in class. I know it's been a while, but the best thing to do is circle the smallest side on the leftmost triangle, circle the smallest side on the rightmost triangle. Those 2 sides are corresponding. Circle the medium side length on the left triangle, the medium side length on the right triangle. Those 2 are corresponding. And then the largest sides, they have to correspond. So 18 and 27. Okay? So now what you are going to do is we are going to set up and we're going to see, are all these proportional sides, when I divide them, do they equal the same value, the scale factor? So we're going to divide the 2 sides. So we want to see, does 10 over 15, does that equal the same thing as 14 over 21? And does that equal the same thing as 18 over 27? So we're trying to see, do all 3 of these corresponding sides equal a set scale factor? If they do, the triangle is similar. So this is kind of the case where you can use fractions or decimals as long as you show me the work. But 10 over 15 becomes 2/3. 14 over 21 reduces 2/3 or 0.66. 18 over 27 reduces 2/3. Since they reduce all to the same fraction or decimal, those all three sides are proportional, which means the triangles are similar. And they are similar since it's all three sides that we're using by side, side, side similarity. Okay? And let's write a similarity statement. So we need to match up the corresponding sides. So in this case, we know that FE is going to be similar to NM. And we know that ML is similar to EG. So our similarity with statement would look like FEG is similar to NML. And yes, you must write it in this order. You must write NML in that order in order for the triangles to be similar. You're going to do the same thing in the next one. Well, in this next one, we know nothing about the sides, so let's focus on the angles. We know that one of the angles is congruent, but in order for us to use angle, we need to know two angles. So we need to find both of these third angles and see are any other angles the same. So we do 180 minus 21 minus 93 to get us that angle F. And if you do that, you'll get that angle F is equal to 66 degrees. You do the same thing for this triangle, 180 minus 64 minus 21. To find angle R, you're going to get that angle R is equal to, I believe it's going to be 95. 180 minus, 95. So there are no other congruent angles besides the one, so we just say that these triangles are not similar. And we can't write a similarity statement if they're not similar. So we're done, okay? If two other angles were the same, then we'd be good to go. These would be similar by angle. Number 9, on to the next page. So looking at number 9 again. So first off, we do have a set of angles congruent. We have a set of vertical angles. Now we need to figure out, and we need to match the corresponding sides. So this triangle on the left, the smallest side of that triangle on the left is 15. The smallest side of the triangle on the right is 21. So those two are corresponding. And then 28 and 39.2 are corresponding. Same as before, smaller side to smaller side, larger side to larger side. So now we want to set up a proportion, 15 over 21, and we want to see, does that equal 28 over 39.2? We're not solving for x here. We're just going to say, is 15 over 21 equal to 28 over 39.2? If these decimals reduce to the same thing, then yes, the sides are proportional. So if you were to plug in 28 divided by 39.2 in your calculator, you're going to get 0.714. If you were to plug in 15 divided by 21 in your calculator, you're going to get 0.714. Since they are exactly the same, that means that my two sides are proportional. So these two triangles are similar by side, angle, side, similarity. And our similarity statement, we know that M has to be in the middle because it's corresponding in both. So if we have here, let me move this out of the way a little bit, PMK, it's going to be LM. There we go, LMQ. Okay, and for the last one of this little bunch, I believe, no, a few more after this, but we want to say, are they similar or are they not similar? So we have that one angle, so we're talking about the smaller inside triangle to the big triangle here. So we want to say, are they similar? So we have one pair of angles congruent. Is there another? Remember, they share, let me do it in red. Both triangles, the smaller one and the bigger one, share this common angle right here at top. If you want to draw them separately and see, they both share angle E. So that means angle E is the same. It's kind of like the reflexive property. It is the reflexive property. So therefore, these two triangles are similar by angle, angle, similarity. So it would be DEF, so DEF is similar to CEJ. So triangle, let me scroll a little bit, CEJ. Okay, and let's get to 11 and 12 before we move on to a little bit something different. So for 11, first off, we're going to see any other angles congruent. We know we have one set, here's another one. Vertical angles, so therefore these triangles are similar by angle-angle similarity. We don't know anything about the third triangles. We don't have lines parallel, anything like that. The third angles, I mean, we just know that those two, but that's all we need. So we could say, okay, triangle STU is similar to triangle WVU. Match up the corresponding angle. And last but not least in this little bit is we are going to compare. There are a few different ways we can do this. We can use all of the sides. In this case, we have shared angles that we can use. So we are going to look at this and we're going to compare the smaller triangle to the bigger triangle. Okay, so the side lengths for the smaller triangle are 35. The side length for the bigger triangle is 49. The side length for the smaller triangle over here is 30. The side length for the bigger triangle is 30 plus 12, which is 42. So let's divide these. So we're going to see small triangle, big triangle. So is 30 over 42? Is that the same thing as 35 over 49? And is that the same thing as we have our last two sides over here, which all kind of make a square around 25 over 35? Okay, and if you reduce all of these, you will get all single one of these, every single one, all three reduced to 0.714. So since all three of them, if it wasn't all three of them, it wouldn't work. That means all three of these sides are proportional. So this triangle is similar by side, side, side similarity. And the similarity statement, and you can check yourself, would be PRQ. Okay, there is another way to prove these triangles congruent. Because these two triangles, the green and the blue, share this angle here, angle R, you could have also just used the side lengths, not the bottom ones, the side lengths next to R. So these two and that top angle, and said that they were similar by side angle side similarity. For this one, that would work as well. Okay, so just show these two and that top angle R is congruent, and that would be side angle side. But if you needed to do side, 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 or wanted to do side, 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 you would have to show all three are equal to the same thing. And I gave you a whole bunch of examples of are they similar or not. We did these notes before I was out, but then you have the example, the extra examples. You can refer back to my worked out notes, anything you need for some extra examples. Email me. I could also send you worksheets, anything you need. 13. So kind of the same idea. Determine if triangle DEF, so this triangle is similar to 1, 2, or both. So we have our angle here. So all of them share that angle. So we're going to be looking for, are they similar by side angle side similarity? So first off, I'm going to circle all the smallest sides. So this is the smallest side, this is the smallest side, this is small side. So I'm just going to start out with triangle DEF, and I want to see, is that similar to triangle 1? Okay, so I'm going to ignore triangle 2 for a second. So I'm going to look at it and I'm going to say, okay, is 10 over 12, is that the same proportion as 14 over 15? If it is, then these two triangles are similar by side angle side. 10 over 12 is 0.833. 14 over 50 is 0.933. So they are not going to be similar. So 1 and DEF are not similar. Now we're going to do the same thing with DEF and triangle 2. So we're going to say, okay, 10 over 18, smallest two sides. Is that the same thing as 14 over 25.2? So 10 over 18 reduces to 0.55. 14 over 25.2 reduces to 0.55. So yes, since they're the same, that means these two proportional sides, these two corresponding sides are proportional, and the angle in between them is congruent. So therefore, the triangles are congruent by SAS similarity. So that means triangle DEF is similar to triangle 2. In this case, I'm going to use the letters. So what is triangle number 2? And make sure you match up the proportional sides, but it will be triangle X, Z, and then Y. So the ones that I have circled in green are similar. Triangle 1 is not similar to either one of them. Okay, and you can freeze this many times if you need to and go through it if you have any questions. And on to the last page. The last page says, find the value of X that makes triangle ABC similar to triangle RST. So looking at this, the very first thing we want to do is say, they're giving us essentially what is a similarity statement, and they're saying, hey, can you make them similar to each other? And this would be the similarity statement. So let's match up the corresponding sides. So AB and RS. Because there's X here, you can't say, oh, these two are the smallest, these two are the middle, these two are largest. Go by the similarity statement. So AB is first and second, RS is first and second. And then we have BC, second and third, ST, second and third. And last but not least, we have AC and RT. Okay, now we want to find the value for X. So we need an equation. We're going to set up a proportion that involves X, just like we did before. So to set up this proportion that involves X, I'm going to start with the X plus 2. So I'm going to start with the left triangle. So X plus 2 over 44 equals, and if I already have X in here once, I don't need to have X again. So I don't need to use the 3X plus 1 in the 7, because I don't need another X. So I'm going to use X plus 2 over 44 equals 5 over 20. We want like a scale factor. So the other expression should only have numbers in it. That makes your life easier. So now I'm going to cross multiply. Use parentheses to do it. So 20 times X plus 2 is equal to 5 times 44. Distribute in. 5 times 44 is equal to, where am I? 220. And now I can solve this. I'll get 20x is equal to 180. So x will equal 9. Please understand there is more than one way to do this. You could have done 7 over 3x plus 1 equals 5 over 20 as well. But I tried to just use the x plus 2 because it seemed easier than 3x plus 1. Okay? If you would like to see me work out any of the problems in a different way, or you would like me to specifically check one of your problems, you can send me a picture and send it to me on Remind or email, or just send me a message, when you submit it online from yesterday, just send me, hey, can you look at my number 10 or my number 5, whatever you need. 15. So this is all the stuff we end the review with stuff from 8.4. Now I know I've been out for 8.4, so I'm going to again review this. That's the one you have the lesson video for. Go back and watch it. You did a big ideas, you did a quizzes. Overall, they were very good. So we want to find the length of AB. So to find the length of AB, I'm just going to call it X. And what we did in 8.4 was we said we could compare, as long as the two sides are parallel, we could compare the pieces. So x over 9 equals 8 over 12. So I always like to say top over bottom equals top over bottom. Okay, in this case, top over bottom, so x over 9 equals 8 over 12. You could also do x over 8 equals 9 over 12. That is fine too. You will get the same answer. I always say piece over piece equals piece over piece. But if you're going to go left to right, you go left to right. If you're going to go top to bottom, you go top to bottom. Okay, cross multiply and solve. So you're going to get 12x equals 72. So x is going to equal 6. And we called AB x, so it's just AB equals 6. Okay, same thing for this one. So I'm going to go top to bottom, top to bottom. So x plus 5 over 15 equals 5x plus 1 over 35. Top over bottom, top over bottom. I'm going to cross multiply. 35, use parentheses, times x plus 5 equals 15 times 5x plus 1. Distribute. 35x plus 5 times 35, which is 175, equals 15 times 5 is 75, x plus 15, and you can go and solve this. You don't need to watch me solve this, but x would end up equaling 4. And you can plug in, see if they're proportional. It should check out for the problem. Okay, and our last two. So remember, this only works if they're parallel. So going forward to 17 and 18, it says determine if DE, so determine if DE is parallel to AC. So in order for these two to be parallel, when I divide the pieces, as long as I get the same thing, just like we kind of did before. So piece over piece equals piece over piece. So I'm going to do 6 over 15, and I want to see, does that equal 10 over 36? So if I do 6 over 15, I get 0.4. If I do 10 over 36 in my calculator, I'm going to get 0.27. So that means if these are not equal to each other, then the lines DE is not parallel to AC. Okay? If they were the same, then yes, it would be parallel. So for this one, we can't start this unless we have the whole, so we only have the whole piece, we want part of it, so we're going to do, in order to figure out what AD is right here, before we even start this problem by figuring out, we want to know is DE parallel to AC, that's what they're asking us. We need to find this little piece in purple. So to do that, the whole thing's 64, and DB is 28, we would just do 64 minus 28. So that would get me that this piece right here is 36. So now, what we can say is we could say, okay, so however you want to do this one, if you want to go part over whole equals part over whole, or you want to do 36 over 28 equals 20.7 over 16.1, doesn't matter, that's the way I'm going to do it. So 36 over 28 equal, so we want to know, is that equal to, I should say, 20.7. So in this case, I'll go left to right, over 16.1. We want to know, are they equal? There's nothing to really solve there. So this gives me 36 over 28, 1.28, and we want to know, does that equal 20.7 over 16.1? We'll get 1.28, so yes, it does. What does that mean? Is DE parallel to AC? Yes, they absolutely are. Okay. You could also, like I said for this one, do 36 over 20.7 and see, is that equal to 28 over 16.1? That would work too. A few of you may be thinking, well, can I do part over whole equals part over whole? So say 10 over 46 equals 6 over 21. Yes, that would work as well. So if you prefer to go back to kind of what we did in 8.2 and 8.3, be my guest. This is from section 8.4. So the last four are from section 8.4, but you can also kind of do them the way we did in 8.2 and 8.3. That would be perfectly fine with me. Okay, from here, what you are going to do is, hopefully you went through this video, you have plenty of time in class, so you did your review yesterday. Now you can go through the video, check yourself. I'll also be posting just the answer key to the review. Make sure to help each other out, and if you have any questions at all, send me an email. I'm hoping to be back on Wednesday. If that changes, I will let you know, and I will push your test back accordingly. If I am coming back to school, I will let you know. You will have your test. I will answer all your questions before and during if needed, and I should be in before school for help as well. I hope you all are doing well, and I cannot wait to see everybody when I get back. Have an awesome day, guys.